Moin and welcome, Code Talks.
Hello, warm welcome from my side as well. Great that you're here in our session, and I was no energy or what?
Everyone's sleeping. It's a cinema.
Really?
That's what you do in a cinema.
They've got relaxed seats as well.
The premium seats, first row. How is it? Is it good? Yeah. Sleeping already? We'll try not to give you the chance.
Hello, everyone. Come on.
That's pretty loud. Good.
Cool.
So we are here to solve all our problems as usual. And I think each time we start a session, we start with, we have lots of things to talk about, probably more than this session is long, so we need a full day at least. Hope you have time. The second thing, we think it's the most interesting time ever to be in software development. But I think I'm saying that for like 19 years constantly. There's always something new that I think this is the new it. And obviously, I think this is the new it. So we will be talking about coding agents, obviously, as you know from the title. The topics we will cover is GitHub Coding Agents, MCP servers, including custom ones, and something called Spec-It. The last thing, Spec-It, works for non-GitHub Copilot as well. So if you're not using GitHub Copilot, any other AI, that works as well. So before we get into the details, because we have so many things, we've done a session last year. I'm not sure if you've been here last year. We've done a session last year. We showed you something, a technical preview of GitHub that tried to turn a single sentence into working software, but it didn't do it by just taking the sentence and writing code. It went through creating a specification, going back and forth with the AI, helping me as the one writing the requirements to, create better requirements, and at the end create a plan and then do the code writing. The idea was to get higher code quality by not just directly writing code, but talking about high-level concepts and requirements first, which you probably do without AI as well, right? Requirements first? Somebody? Maybe? Requirements later? Okay. First of all, who is not using AI in his daily business these days? I can't put my hand up. Not too many. Who is not allowed to use AI tools in your business today? A few, okay, but not so many. So let's just do the checksum. Who is allowed to use AI tools? Who is using AI tools? Why is it less that are using it than they're allowed to use it? Okay, we have to change this one, but most of you said they're allowed to. That's good to know. So again, last time we tried to show you this, and it was a technical preview. Things were a bit wild and rough, and we knew that. And we tried to create a game called Pipeline Invaders, and I still have it with me. And this was it, the demo repo from last year. And what we've done here, where is my mouse? There it is. I have to a little bit hope for the best with the internet today. It's as with every good developer conference, internet is something unexpected to work properly. And if you click on issues and hope for all the best.
I'll try.
So this is the same code we had last time, and the code consists right now only of a README file explaining the necessary steps, not more and not less. And so what I will do is just write a single issue. Let's take this one here. See, why is it so slow? Somebody said the cloud is a good thing when internet works. Who believes that too? So that's the issue I'm talking about. And the issue is basically just implement the game as we wrote it, the game concept. Mark actually wrote the game concept in a README MD file. This is one of the places the AI will look at. And make sure the player can win, make sure the score is counted correctly, make sure there's a health level counted, the stuff you need for a Pipeline Invaders game. And just switch over to see if that's maybe better because of the routing thing. It's not worse, at least. And so when we talk about the GitHub Coding Agent, what we mean is your job is to write issues. You write the intent, what you want, the acceptance criteria. This will be 80% of your job, if not more. And then you click this button, Assign to Copilot. And now some virtual team member called Copilot will work on it and call you back when it's done. And you can do this not for one issue. You can do this for 2 or 3 or 4 or 5 in parallel. And you go and do something else. Actually, at the end of the day, probably it's always waiting for you because you have to write all the issues and you have to write them pretty concise to get good results. So there's more work for you, really, but it's not coding anymore. This is done somewhere else in some secure environment on a VM. It's actually spinning up a VM, right? And
yeah.
it's working on a VM.
It's a GitHub Actions environment. We'll go into that detail later on, but actually it uses the GitHub Actions environment. You're actually building your software usually, runs an agent in there, and implements it for you.
So you see it's assigned to Copilot. It already started thinking about it. You see the smiley, like a real human. It would say the eyes. Oh, I'm looking at this. And a few moments later, it will open up a pull request, work in progress. It will now work on the whole application. It's a whole game, right? It's from zero, from scratch. It will take roughly 30 minutes. So we'll check back in 30 minutes, I guess. And that's all it takes for using GitHub Copilot Agent. So thank you for attending our session. You've been a wonderful audience. Really appreciate it. Thanks. They don't believe we are going now. We have to maybe get out of the room.
Yeah. But it's actually that easy. But there are a lot of things behind the scenes you need to know. And we've got a little bit more content, to be honest. But let's continue on that. So we see the result. It's a simple click, but there's way more going on than just assigning the issue.
We have way too much content. Anyway, so we like to go back a little bit to understand clearly where the benefit of the current situation is. And again, those tool sets are evolving so fast that whatever we showed you last year is not available this year. Whatever we show you this year probably looks totally different next year. So we'll focus a little bit more about concepts, things that won't change, things that are important, so that you understand in what direction you want to go. It's not like a one-to-one thing that you can use in daily business, just to give you ideas and clear up the concepts and the basics that you need to know. So where are we coming from? Well, GitHub, as you know, is a Microsoft company these days. And Microsoft has the best records and high-quality AI tools for a long time. So I think we're betting on the right thing if we look at the Microsoft products first. They're a market leader in that space, so let's look at it. And if we go back, actually 2021, that's 4 years ago now, Microsoft started, or GitHub started with the first AI tools. And it focused around autocomplete. We'll look into this. And then it moved on, 2023, with chat features. You can ask the AI, the LLM, and the AI bots. The third generation is this year, where agents appear. It's the first time we hear the term agents, so something's different why we have to talk about agents. And what we want to talk about, and Mark will show us some nice demos, is this virtual team members coding agent thing. And most of the other tools are doing something similar, but GitHub Copilot is kind of ahead, so this is where we look at mostly. So going back 4 years, so the first tools around were tools to help you while you write code, right? You open the code editor, you start typing. What's interesting about when you started typing it, it even helped you fulfill the comment. So I started with the comment, and it helped me write the comment, and then once the comment was there, it helped me write the code, and that's, I press tab all the time. So my tab key is actually the one mostly used on my keyboard now. So I have to buy now and then a new keyboard just because of the tab key these days. That's new. That hasn't been the case. What's also interesting when I prepared this, actually, you can have typos. I have an explicit typo in the first word. You can have typos, doesn't matter, because again, it's all about probability. It's not intelligence, so it doesn't matter if you do typos. You can mix languages, half German, half English, doesn't matter. You get a different result, but usually it gets the right context set. What's also interesting, and you have to always remember that, all those tools have no idea what software development is and what they do. They just do math and probability. So once I was writing this in a live demo, and I started in the next row, it suggested me copyright name by a name of some person on this planet I don't know. Like, why is it suggesting a random name? Is that even legal? Where does it get this name from? So this is how it started. It was nice. And then ChatGPT and the rest came into play, and then they had to, okay, so it seems like chatting is something we want to do. So you probably all tried with ChatGPT to do things like, oh, I have something I don't like to do. It's actually a regular expression. Can you help me do regular expression? Of course it can. especially the models we use today, like GPT-5 and the Claude models, they are super expressive. So usually you ask a tiny question where you would expect your colleague to say yes or no, and it will respond in like, oh, here are 500 versions how you can do it. Like, can you do a little bit less? So because they're so strong and so good, they give you way too much. Same with code, by the way. It won't just give you one little code file. It usually creates like a whole project with side projects, and it's super easy to get a really overcomplicated thing. So in terms of emails, you get this whole thing, there's an RFC, but the first sentence, I would not try to match the RFC. Not the standard? Why? And the revolution with chat was that you don't just get an answer like Google or search, but you can chat. You can ask, okay, I want to know why did you recommend this? Can you do it more explicit, or can you suggest alternatives? And so you can answer and say, okay, what do you suggest if you tell me to not strictly match the RFC? And then, okay, it's probably enough to look if there's a few of the most important things in an email address. So if you're in the business of checking email addresses, the answer is don't. Actually send the email, and then you know if it works. And now this year, the first time we hear this term agents. So what's different between we could chat with AI and LLMs, and now we have this agent thing? So the agent is defined as, it starts with a trigger at the top. So you have some, your user entering something, or you are in the code editor, or it's just once a day, and you have this prompt. And this prompt now is an intent. So you define the goal, the desired result that you want, and then the LLM starts. And it goes into this loop. It checks, have I reached the goal yet? No. Then I will call for help. I will call tools, like I will open the browser and look if I find the data. I will look into the official documentation. So it can do things on itself, gather more information, run tools in the command line, create files, save files to a pull request. And it continuously does this until the goal is reached, or in some cases, the parameter max iterations, which is like...
Yeah, or your money runs out, maybe.
Your money runs out, or like there's some security mechanism, because you could run it to an endless loop, and to not have an endless loop, you can set a max iterations, and then AI will stop and ask you, shall I continue? It looks like it's a long thing I'm working on here. And then you can say yes or no, and once it reaches the goal, it's done. So instead of you having to write in the chat version, having to write things like, hey, I think you're not done. Can you continue? Oh, yeah, sure, I'm not done. You're right. Oh, are you sure this works? Oh, no, thanks for asking. It doesn't work, actually. Let me look at this again. So it's asking itself until it's really done.
Yeah, so practically, to just have an idea of those tools, so in software development, those tools are calling a compiler, running the unit tests. So those are the goals which are set in this intent, and it actually tries until you have 0 errors in compilation, all the tests are green, and tries to really do your software, not just write some code and just gives it to you. It's really finishing the task.
And you can also have your own custom tools, which is what we'll show you later, because maybe your environment is special and the LLM needs access to your personal log files of your company to be able to do something useful, right? So you can write your own tool to allow that, or find a tool that does that already for you. So that's really a little revolution. So if somebody would have asked me last year, okay, this all looks nice, but what's actually missing? I would have said, well, large language models don't know how to program. They know how to, again, build strings out of probabilities. They don't even know if this works, if it compiles, if it would ever run successfully in production. And now the answer is, it still doesn't know it, but it can run a tool like your compiler, and it sees, oh, it's actually red. Let me rethink. Or let me write a test. Oh, the test is red, so I guess something's wrong. Let me rethink. So it has feedback that is not me as a human required. It gets feedback from another source and continues refining until it thinks it's done. And if you watch AI work, I would not recommend that, actually. It's like watching the worst intern in the world do totally stupid things. You would directly fire him if you see how they work, especially the AI, same thing. So I've observed like Copilot running a command like, oh, the command is not found in this directory. And then it just says, okay, what's the most probable thing if you get an error message on the command line, file not found? What's the most probable thing you could do? Go into a different folder. Like probability says cd ... is the most probable thing you do. It has nothing to do if there is actually something in the, it doesn't look at the owner above, it just tries. cd ... seems to be reasonable to solve this problem. Oh, it still doesn't work. Well, you're looking at a completely different thing. So those are the things. And I have a few more examples if you want later, how stupid it actually is. So it's still not intelligent, but it just repeats itself without bothering us. And as it doesn't bother us, we're good. Hopefully good. So another thing, example that I really like is when you also add vision to it. So I try to create the worst possible input that an AI could get from me. So this is a hand-drawn Azure architecture chart by me.
Sophisticated.
So if you need a consultant that does highly sophisticated Azure charts, feel free to call me. And so I want to end up with the architecture. So, Terraform scripts, everything, using modern best practices. And that's what I can do by just, so you've seen this. I've taken a picture. It's not focused. It's not perfect lighting. I did a few mistakes on it. I didn't, my handwriting, so many things. And still, the AI doesn't care. And it doesn't even blame me for my handwriting, which is what a real colleague would actually do, right? So,
yeah.
So here's the image. And I put this into agent mode because, I don't want to do all the answering. I want it just to work. And now what could the question be? Check the, internet. Attached Azure diagram. Casing doesn't matter. It's like for young people, you just write. No dots, not required, just write. The attached diagram contains my desired arc. Arc is enough for architecture, right? Probability, it's probably clear what's meant. Please use this and create all required infra code in my repo. It's too much text, isn't it?
Yeah.
Yeah. Using Terraform. Use best practices. And what's also the most important thing when you talk to AIs?
Please, thank you.
Please or thank you.
You never know.
You never
if
know.
They're
AI
coming
takes
back.
over, you never know. Just be safe. I know, it costs some energy. I read that too, but it's a balance.
Oh.
So now it will tell you, okay, this is what I see. And I see there's a browser, there's a firewall, there's a VNet containing, there's this, there's that. Let's activate the best practices tool. So the first thing, it read the diagram. The second thing it does now is, and it's actually correct what it does. It's just, if you only ask for the diagram, you get a more detailed version. Since it's just using that, it's okay. But it's correct what it found. And now it's after it analyzed the diagram, it actually found out that there's an MCP server, so a tool function that it can call to get the latest best practices for Terraform in combination with the Azure cloud. And this is what it's calling now. So it's like I would copy paste from the website of Terraform all their best practices. That's what's happening. So it's inserted into this whole prompt, and it's been used for the generation that happens now and happens next. This can be slow, depending on which model is working on it. Right now, we're using the auto model because I'm one of those guys thinking, I really don't want to get into this business. What's the right model for my job? I don't know, and I don't care, honestly. I want the AI to finish the job, whatever it is. Luckily, in VS Code using GitHub Copilot, there's this auto button, it's pretty new, and they try to infer which is the right model. There's a different cost to it, and depending if you analyze requirements, or if you write code, another model might be the right choice. And there are best practices articles on the internet, but I just don't want to get into this business. Okay, let's just do it, but you see on the left, main TF, Terraform, outputs, variables. So everything you've seen on my beautiful architecture that follows all the best practices there are is now written in a ready-to-deploy form, and I've deployed it, it actually works, and that's the new beauty about agents. It still doesn't know why it works, but it knows which tool to call to get help, to get best practices, and to see if it compiles and works what it does. So again, still not clever, but better than what we had last year. Significantly better than what we had last year. So if you want a more marketing version of how an agent looks like, this is how Microsoft envisions it. So it's the same thing I've drawn before, but just fancy. So if you need this for your company to convince somebody else who's not into my handwriting, this is what you probably want to use. So when you look at those 4 years of evolution, each year really marked a step that was not thinkable the year before. So when we started 4 years ago, it was really the human was the one working, and the AI was just suggesting a little bit, like, oh, I would do it like this, maybe it's wrong, it's your choice, just suggestion. Like Clippy, really, Klammer, Clippy. Generation 2 was, okay, you as a human ask a question, and ChatGPT or whoever would respond and tell you an answer, okay. And now we reach this agent state where human and AI work together. Right now, it's really working together. And it's your choice if it's something that's so important that you really want to supervise, so work with the AI at the same time in your IDE, Visual Studio Code, for example, or if it's something you want to delegate to the coding agent and not even see how it's doing it. You remember it's still building that game that we started at the beginning. It will do this for 30 minutes, and I will just check the end result. Because it's okay, it can't break anything. It has no access to my critical systems in my company, so what should go wrong? Speaking of which, it's all about context. This is not new, but if you now have an agent that can run in loops more or less forever, now you have to be sure what it does and that it creates good quality. And it can only create good quality if you have enough context information. Just to remind you, this is not new. Context is whatever you give him into the prompt or the IDE tool that you're using, like Copilot, the extension is doing. This is Visual Studio Code. I'm writing a new class in C#. That's the language I'm coming from. And I want a conference details class, and it suggests me a class in C#. What's interesting is, this is not what I expected. Why? It's not using C# naming conventions. It's using different naming conventions. It's using description tags that I've normally is not the normal case in C#. So why has it done two things that are not normal, and probability should not say that this is the most probable thing? And it's because of context. Do you see the open tabs? Two other classes are open. So whoever's been in this project seems to have used this other naming convention. And now the extension says, okay, this is my context. This is how you already started writing your project. I would just follow. Or as other colleagues say, if you write really bad code, Copilot can help you scale this. And that's the point where somebody would say, well, I could that without Copilot. But anyway.
Yeah.
So an alternative to opening up tabs is obviously providing instructions. You probably know there's an agents MD file, but most of the tools are also looking at the classic places, like there's a README MD file, a contributing MD file. You can have a .editor config file, which most editors are looking for naming conventions and stuff, white space conventions. And this is how GitHub Copilot does it, so-called instruction files, and you can limit those files to certain file types, like for Terraform, for C#, so that you can put your preferred naming conventions in there. That's it. That's where we're coming from. Now we're at this stage where we can delegate things to this invisible coding agent doing work somewhere else. We can have many of them working, and I will tell you, it's a lot of work. If finally you have unlimited virtual team members, all you have to do is write specification. That's a different job, and it takes time, and you can do lots of things wrong. However, the good news is, if you just try out something and you don't like the result, just delete the pull request. If this would be an actual human, worked for a week, and I delete your pull request because I don't like your result, that's a different thing, right? But since it's just AI generated, just, okay, it's not what I wanted. Let's go ahead, let's do it again. So maybe we can look at some more serious stuff than
I'm not serious.
Than my pipeline invaders game from last year.
Let's see.
Let's see if your screen appears and the internet works.
Great. At least we see a screen. So let's try to see that actually in action. So it's still a fancy app, not that professional. So I built a small fast food application. You can order things here. You just buy them and paid. And then you have a kitchen monitor, which obviously didn't work, which is not the error I actually want to show. So the thing is, if I'm ordering...
You're lucky that the sessions be after the lunch break.
Yeah,
because if you do
people
that
get
right
hungry.
Before the lunch break, people would just go out and hate you for showing like burger pics or something.
The thing you notice, I added the cheeseburger 2 times in a row, and actually I would expect that we actually get 1 item with a quantity of 2. So this isn't that ideal, and we want to play that through, actually. So let's start and try to get an issue here and try to get the coding agent working on that topic. So first of all, what I'm doing, I'm in my repository. I start locally because I'm a little bit lazy. I hate writing issues. So I'm just explaining the whole thing and tell, hey, well, use GitHub and create an issue for me. This is not working. I'm expecting a different behavior. So we can actually call tools like here #GitHub, or here I'm using #Playwright to say, well, you could use Playwright to actually see that error by yourself. So I'm prompting my local agent for now, acting on my own as Mark here, and it opens up the application, tries to figure out, it takes screenshots, it goes through it, adds the whole items to the shopping cart.
So is it just because you're lazy to create a bug ticket on GitHub?
Yeah.
Yeah. Okay.
I'm not that good in writing tickets, actually. So it actually tries to go through my description and does it in a way more professional way that I could ever do. So it runs a little bit. It actually adds 2 cheeseburger to go through that case again. And hopefully, within a couple of minutes, perfect, I can see the bug clearly. So it's writing an issue for me. Let's see that.
So you mentioned that like you had 2 MCPs, like 2 tool providers running. One was GitHub, obviously, to create the issue. The other one was Playwright, and that's like browser automation, is that right?
Oh, yeah.
Let's re-authenticate because your Wi-Fi changed.
Yeah.
Do you ever have that in real life? No, right? Authentication issues? Never, right? No.
So let's see that.
Who has to authenticate more during the day than actually work? Me, certainly. Okay. It's a known problem? Yeah. I hope those passkeys will solve this or something. Some magic thing will happen. That would be like a productivity boost of 50% for me, just solving the login problem on various websites.
So let's wait for a couple of seconds. So currently we are local. It's still the GitHub agent mode. We are using more or less the same concept later on in GitHub with the coding agent. So I can go back and forth having something locally where I can interact with it, or then use the other part we're seeing in a second.
Just a funny addition, because you were in Visual Studio Code. Like the stuff that we're going to show you now is obviously GitHub.com based, so you have to have your code on GitHub.com. But what you've shown in Visual Studio Code, like use Playwright, create a screenshot, create a bug ticket in whatever system that has an MCP provider. I could have done this for GitLab or Azure DevOps or whatever I use, right, or Jira.
Yeah. And here we see the issue. So way more professional than I could ever write that.
This was all written by...
Yeah, everything by my agent. So beautiful. And what we learned from the beginning, now we need somebody to work. We need a new teammate who actually does the work for us.
Now I need Copilot to summarize because it's too long to read.
Okay, so I'm choosing here Copilot. Let's do that. Assign Copilot to work on that issue. So we should see in a second that those eyes are watching the issue. So let's see.
You can zoom out a little bit because
it's too big. Yeah, we're in a cinema.
It's not big.
It's okay like that, or still? Is it okay like that? Okay, great. So it created a pull request. So we see there's a pull request. It's in work in progress state. It starts working on it. And what we should actually see in a second is that we have the initial plan, and it should start now a coding session. So this coding session is always in a dedicated, isolated environment. What they use at GitHub.com is they spin up an action runtime for you. So the same thing, you would build your software, do your deployment, whatever. So they have GitHub Actions context. They run a pipeline, a special pipeline, a Copilot pipeline. We will see later on we can extend that pipeline for customizations. And then the agent runs in that action context. So it has an isolated environment. We have firewall settings. We can exactly tell the Copilot what the firewall rules are, what tools it could use. So it's a quite secure environment, or we need to protect it, because actually it runs somewhere in the cloud, has access to our code, and could do also bad things. So what we can see here is there's a session. So we actually see now this coding agent working in this environment, doing the stuff. So we can really read through it, say, okay, it's going to check the code, goes on and on. We see on the right-hand side what it's actually providing. We will see files in a couple of minutes. So it actually goes step by step. And what we can see here is this actual agent loop. The agent loop always reflects, is it okay what I'm doing? Is the code compiling? Do I need to add some tests or the test screen? So it goes on and on and on until our goal is met, or the goal I presented in the issue. So let's do a quick fast forward, because yeah, I did this morning, and actually it ran, I can't read, for 30 minutes here. So it went back and forth, and I didn't write any tests for this demo. So it was like, oh, we should write some tests. And wow, your architecture is quite complex. It's quite hard to write some tests, but it did it. So at the end of the day, I've got a fully working software. What we also see is, since a couple of days, this is the whole discussion, or the agent mode working with its own. And what we can do since, I think, a week or two, when it's working, I just need to scroll down. You see, it did a lot. So I just saw something was not okay. And within this session, I was able to chat. So usually you just check it out some minutes later, or when the pull request is there. If you are watching this and you see something, now you have the possibility to actually provide some chat messages to correct some behavior a little bit.
Why can't we get this for emails? I always send an email like 5 seconds later, oh, I forgot half of it.
Yeah.
So maybe that's the same thing, but you don't have to wait till 30 minutes. You can actually chime in and tell him, and it will break after the next function call and see what you told him or get the feedback.
Yeah. Actually. Yeah, and well, this is the pull request. We see the pull requests get updated. So it's no more this initial state. It wrote a complete summary, what actually changed. We can check the files. It also requests my review, so I'm still in control, whatever it does. It's a pull request. There is nothing going to be integrated without my approval. They even don't run your pipelines automatically because the AI could do something wrong. So you're really in control, but you get a pull request like your colleague would provide it to you with maybe a little bit more text than my colleague would provide, actually. And the cool thing is I can add new comments. So it's still a pull request. It's back and forth. So I saw another bug and was like, yeah, it's great what you did, but could you just fix that as well? So it's an ongoing discussion. Every time I'm calling out Copilot with adding add Copilot, it actually starts a new session implementing the additional thing or corrects a mistake that I got the error, or that I got the result I wanted to have. So we can quickly check that out if it really works.
And the coding agent is never tired.
Yeah.
The coding agent is never angry. It works whenever you need it. You can have multiple IDEs open with multiple sessions, or just on the GitHub side, you can have multiple agents working for you. And it always creates a screenshot by default and updates it for every change in your pull requests. That's work I would never do manually, but that's nice.
So let's see. I've got a local build, and let's see if it's fixed. Here we are. Now, if I add multiple items, it adds or sums them up. So let's add 5 here. So it should be 6.
Nice.
Perfectly solved. So we got a new teammate solving our issues.
Nice.
That's what we wanted to have. And it even wrote tests without asking. That's the biggest thing, actually.
It's really impressive, and especially like it sometimes ignores you. Like it writes tests you didn't even ask to. In my case, it found that I left a docs folder, and in the docs folder I had an overview MD just stating I should document my architecture at some point, including current prices of Azure. I forgot about this file. It hasn't been updated for a year, so I asked for a bug fix for something, and then my whole documentation folder was ready. All the, with drawings in there and the current pricing fetched from the website and added and everything. Like, who did that? Oh, it was my bug fix, and I didn't. But that's like the bad thing. It does things you didn't explicitly ask for. That's kind of weird, but not forbidden, though.
Nino, we have something else. Our production system is down, so we deployed it to our production.
And it's not the Wi-Fi here, right?
No, it's really not the Wi-Fi. Well, I did it intentionally. So we've got an issue. Our production system is down. Our burger app doesn't work anymore. Everything is orange, red.
How can it be down? Only AIs are working for us. Where can there be a problem? Right?
So let's try. We've got, I think, 6 minutes left. So let's try that.
If you talk faster, we have 12 minutes.
Yeah, I'll try to.
We have 10 more things to show
yeah,
at least.
Yeah,
so
yeah, we are.
good.
So, what else could we do? I created a SRE repository. So we try to use that coding agent as a site reliability engineer. So we do a special role for it. So what we have here, there is this alert. So we have our alerting system, our observability system, and it created this issue. So what we learned is, well, let's just do that. And I'll come to that back in a second. Here I'm choosing a customized agent. So I call this one SRE agent. We'll come to that in a second. I just need to start running it because it takes around 3 to 4 minutes. So I do the same thing, but with a special role of agent. So there are a couple of things I changed here. First of all, let's quickly, we just keep that running. I quickly duplicate this tab.
And just to be sure, right, the coding agent is meant to be used for coding only.
Yeah.
But we're trying out what you can do. I mean, why not do SRE things? Why not help you write documentation? You have to try out things, right?
Sure, sure. So what we did is we are able to create custom agents. So how do I define a custom agent? It's that simple. It's an MD file, a markdown file, and I'm just describing what this agent should do. So in this case, it should act as an SRE agent, trying to get the system up and running. It has tools, so I installed a couple of MCP servers. In this case, I installed a server for our software with a knowledge base that it could get some usual error handlings and failures. And on the other hand, I installed a Kubernetes MCP server that it actually has access to my cluster, can check the pods, the issues, etc. So how did we do that? And it keeps running, and hopefully it just gets green. So first of all, I need to go to settings. We need to go to Copilot, coding agent. And what I have here is I added MCP servers. So you see there is a Kubernetes MCP server to gain access to our cluster, to actually connect to it. And I created a custom fast food MCP server. It actually has knowledge to our faked knowledge base. It can get feature flags, status, etc. So just some domain knowledge about our application other agents couldn't know. So I just added those 2 MCP servers. There's a speciality here. So as you can see, this special MCP server runs with a volume mount of my kubeconfig file. So how do I get there? So we could just provide secrets to an MCP server, but here I need to provide a file. And it's a great example on how we could leverage that with the customization of this agent environment. To do so, one thing was the MD file to give the context to describe what the agent should actually do. On the other hand, we can just use GitHub Actions, workflows, setup steps, and here we see a small workflow. So it's very important to know that we have here a job called Copilot setup step. So this actual job is executed before it's running the agent. So I can now shape my environment the agent runs in. And here, for example, I'm just creating those kubeconfig files my MCP server is expecting. I'm pre-caching the container images, etc. I could execute anything just to shape my environment that agent runs in. So locally, I have the same thing. I've got my Visual Studio Code, my tools installed, and I can do the same thing on github.com. Using this action definition with a special syntax. It's a predefined job name, that's it. And whatever I execute in here is inside this agent environment. So let's see if something is going on. Let's go to the pull request. We should see the session.
Oh, it's still working.
It's still working. 3 minutes 45.
Great.
We're running line.
Collected component YAML. Okay.
So at least
Call resources, yeah.
It has the right intention to correct the URL.
It looks good, yeah.
Looks good. It just takes a little bit of time. Let's see, it's still red.
It's still faster than any real human fixing DevOps issues. So, I mean, 4 minutes, right? After the monitoring system created an issue. That's pretty good.
Yeah, so it identified the error correctly. It had this crash loop back off. It
And
identified the wrong URL of my Redis server. So it actually is doing a great job. I think it just needs a minute or two more.
Just leave it running, and we can once again talk about that. The coding agent again is meant for coding. That's what it's done. It's specifically good for existing code bases. Fixing bugs, adding tests, adding documentation, refactorings.
Yeah.
Not really for like I have 0, write me a full app because there's too much information missing. However, technically it can do everything. Once you write your own MCP servers or just choose from a list of thousands existing ones, it can do whatever you want. It can research the internet for information. It can find you the 10 best parties of your hometown and create a pull request with Markdown where you have to go. It's all possible. All you do is define the MCP service, write an issue, let it run. It's not limited to coding. Obviously, marketing says it is, but we use it for multiple things, even outside of software development. What is it doing now? It's talking to the
now it
workload,
tries
skip control.
we are getting green.
It's
we are getting
fixing
green
our
again.
production.
It fixed the actual issue. So it just fixed my Kubernetes environment where I was providing a wrong Redis URL.
And just imagine this.
Green. We're green.
Just imagine this happens in the middle of the night. You don't get woken up. You wake up next morning and you see, the website was down for 4 minutes and it auto-fixed itself. Is that nice? So Mark flew in this morning from Switzerland just to show you those 2 demos. That's what he did. Thank you, Mark, for being here. That's amazing.
Thank you.